This is the video for 1.4, extreme and average rates of change. So it should be extrema. So first we're going to look at the concept of increasing, decreasing, and constant. So if your graph, as your x's get bigger, if your y's get bigger, regardless of which way this arrow is pointing, if it leans up to the right, think of it like slope, this is increasing. If your graph stays the same, that's constant. And if your graph goes down to the right, meaning as your x's are getting bigger, your y's are getting smaller, this is where your graph is decreasing. So you are describing what is happening to your y values as your x values increase. So as your x's are getting bigger, your y's are getting bigger here. As your x's are getting bigger, your y's are staying the same. As your x's are getting bigger, your y's are getting smaller. And I want you to use open intervals, parentheses. Don't use brackets on these. I want you to use parentheses because when we do other things this year about limits later on at the end of the year, at one particular point, for example, right here, you can't say that the function is increasing or decreasing there because it's doing two different actions from the left and from the right. So you want to use parentheses on your increasing and decreasing. So let's take a look at the example. So this first part of my graph, as my x's are getting bigger, my y's are getting smaller. So this is decreasing. So next part of my graph, as my x's are getting bigger, my y's are staying constant. From 3 to 4, my y's are getting bigger, that's increasing. And from 4 to 5, they're decreasing again. So I'm going to give the domains of each parts of these. So when I give your increasing, decreasing, constant, you're only going to give me the x values. You're going to list only the x values, kind of like you're doing a domain. So I'm going to go from here to here. So I'm going from, oops, that's too far over. I'm going to go from -4. So my decreasing is going from -4 to 1. And I'm also going from 4 to 5. Those are the two places that I'm decreasing. I'm increasing right here. I'm doing a little spot. I'm increasing from 3 to 4. And I'm staying constant right here from 1 to 3. And so make sure that you use only x values. So you're basically giving me the domain part of this only. So if I want to know where the graph is continuous, my graph is continuous. Let me get on this part and this part. So I'm going to list those two parts. It's continuous from -4 to 3. And then it's continuous again from 3 to 5. Oops, actually from 3, we need to fix it. This is so small, there's an error on here. So actually my decreasing, we need to change that 5 to an infinity. It's kind of hard to see on here. So I'm going to erase the 5 and infinity because I made my graph so low. At what x value is there a discontinuity? So there's a discontinuity. Let me change colors. Right here at 3. So at x equals 3, there's a discontinuity. And if there is a point here and a point here, what kind of discontinuity is that? And that is going to be your jump discontinuity. So be aware that as we go through the semester, when we start doing more things, I'm going to start going back and reviewing more of these things again. And I'm going to keep asking you these same things over and over. So as time goes by and we start doing a lot more piecewise functions, you should be able to tell me more information about it as time goes by. Okay, so then for extremas, we're just going to label them. So you've got two kinds of minimums here. This is an absolute minimum, and a relative. So a relative minimum just means it's not the absolute lowest, but it's still a low part in the graph. And if I do maximums, again, the highest one is called the absolute maximum. And one that's inside the graph is just called a relative maximum. It's not the highest, but it is relative to that particular part of the problem that it's in. Okay, let's look at an example that just deals with minimums. Suppose each of the 75 orange trees in a Florida, okay, obviously I didn't spell grove right. Grove produces 400 oranges. For each additional tree planted in the orchard, the yield decreases by 2 oranges. How many additional trees should be planted to achieve a maximum yield? So if I want to figure out, what my maximum yield is, you're going to take your number of trees times the 400 that each one produces. Okay, so if they're adding additional trees, so for each additional tree that's planted, you lose 2 oranges. Okay, once you do that, basically this turns into a quadratic function. If you were to stick this function, and this is a calculator prompt, into the calculator, you're going to get a function that looks like this. And the part you would need to find is your maximum. Because you can afford, you're basically starting out here, and you can afford to add a couple before and lose a few to still yield a maximum crop. So by doing this on the calculator, you're going to type it in y equals, then you're going to graph it, and then you're going to do second trace to get into the calculate menu, and you're going to do maximum. Okay, or whatever calculator function you have, and you should get that the maximum is 62.49937,812.5. Okay, so this is the number of oranges, or the number of additional trees planted, and this is x equals your number of trees, and this is your yield of oranges. So basically, if I plant about 62 trees, I'll yield about 37,812 oranges. And that would maximize my profit. Okay, average rate of change. Average rate of change is just a fancy word for something you spend your entire first semester of algebra. Slope. Okay, the average rate of change between 2 points on a graph is the slope of the secant line through them. So for example, if I have a function that looks like this, and I want to find the average rate of change between this first point and the second one, I'm going to draw a tangent line, or not a tangent, sorry, a secant line through this. So this is my secant line. And my coordinates are x1 comma f of x1. And then this one is x2 comma f of x2. Or x1 comma y1, x2 comma y2. And so here is my formula. Remember, m is slope. And think of f of x2 as your y2, f of x1 if it helps you to remember that y1. And just think, it's just your good old-fashioned y2 minus y1 over x2 minus x1 problem. So for my example, I want to find the average rate of change of the function f of x equals negative x cubed plus 3x on the interval 2 to 5. So the first thing I need to do is I need to find my 2 coordinates. These are just my x's. Oops, sorry. Not y's. These are my two x's. So I need to find out what f of 2 is and f of 5 is to get my y values. So if I plug in 2, so that's -8 plus 6 gives me -2. So that coordinate is 2, -2. If I plug in a 5, 5 cubed is 125, so it's -125 plus 15 gives me -110. So 5, -110 is my other point. So then if I want to find my average rate of change for that secant line, I'm going to do my y2 minus my y1 over my x2 minus my x1. That gives me -108 over 3, which gives me -36. So my rate of change from one point to the other is going to be -36 in this particular case. See if there's anything else. There's nothing else on here. Okay. So that is the end of 1.4.